Every few years, without any regular schedule or planning, officials at the International Earth Rotation and Reference System Service will add an extra second to the year. The reason why this is done makes some sense, but adding an extra second to a year can cause a host of problems, and many are wondering if it's a practice that should be continued. Learn more about leap seconds, why they exist, when they happen, and if they should continue to exist on this episode of Everything Everywhere Daily. Hey everyone, I want to tell you about a podcast that I think you're going to enjoy called Curious State. If you love asking offbeat questions to uncover magical nuggets of knowledge, you're going to love the Curious State podcast. Every week, host Doug Frazier asks a question like, does language warp reality? Or could we have domesticated a T-Rex? Or is the mafia really that violent? With help from authors, experts, and artists, Doug explores the answers in short-form episodes of 20 minutes or less. A format that I'm sure everyone who is listening to this is familiar with and enjoys. You can listen to Curious State on Apple Podcasts, Spotify, or wherever you listen to this show. Once again, the name of the podcast is Curious State. This entire episode is about 1 second. 1 second which may or may not be tacked on to a year. 1 second over the course of a year may not seem like much, and in a human frame of reference, it really isn't a big deal. If it weren't for the fact that occasional leap seconds were publicly announced, nobody would ever even know that they occurred. Before I get into why leap seconds exist, it's important to know just what a second is and how it's defined, because it's the key to understanding everything I'll be discussing. I've done several episodes on the subject of time. I've talked about why the calendar is the way it is, how the months were named and the order they're in, and why there are 7 days in a week. However, the fundamental unit of time is not a year, month, week, or day. It's the second. Defining a unit of time is much more tricky than defining a physical unit. When the meter and kilogram were defined, they were defined based on an actual physical object which sat in a vault in Paris. There was a literal piece of metal, and that piece of metal was by definition 1 meter. And the same was true with a metallic weight, which was the definition of a kilogram. You can't really do that with a second. A second is a unit of time so short that the ancients really didn't have any use for it. There was no way to track time with such precision, and there were no uses for a unit of time so small. The modern second was created around the year 1000 by the Islamic scholar Abu Rayhan Muhammad ibn Abd al-Biruni. Al-Biruni codified the system of dividing a day into 24 hours, and then dividing an hour into 60 minutes, and a minute into 60 seconds. So, by Al-Biruni's definition, a second was 1/86,400th of a day. For all practical purposes, this is still the definition of a second that we all use today. When the metric system was codified in the 19th century, the base unit of time was the second, and it used this very definition. However, there was a problem. As scientists developed more precise instruments, they discovered that the length of a day could vary ever so slightly. Because the length of a day wasn't absolutely consistent, there needed to be another way to define a second. The next logical step was to simply define a second in terms of a year. The length of a year shouldn't have anything to do with what is happening in the Earth's rotation. So, in the 1950s, the new definition was that a second was 1/351,556,925.9747th of a year. But that too had issues, and it wasn't accurate enough to be of use for the increasingly precise needs of researchers and new electronic technologies. So instead of using an astronomical definition of a second, they went in the complete other direction and used an atomic definition of a second. The definition they selected was that a second was the time it took for 9,192,631,770 vibrations of a cesium-133 atom. Cesium was chosen simply because it has one electron in its outer electron shell, which made it easy to observe. This definition of a second using cesium atoms was very close to the astronomical definition, to within 1 in 10 billion. This is still the definition of a second that's used today, and it's a definition that works well and has been able to work with even more incredibly precise atomic clocks. While decoupling the definition of a second from astronomical events such as a day or a year made it much more accurate, there was still the problem with days and years. As I have mentioned many times in previous episodes, one of the reasons why some time measurements are so confusing is that time units often don't divide into other time units evenly. In the case of seconds and years, here too, with the new definition of a second, it wasn't perfectly divisible by a year anymore. It was really close, but it wasn't perfect. So, just like an extra day is necessary once every 4 years to keep calendars in sync, it's necessary every so often to keep clocks in sync. Generally speaking, there are two different systems that are used to keep track of time. One is called universal time, which is based on the rotation of the Earth. The other is called coordinated universal time, or UTC, which is based on the definition of a second from cesium atoms. The leap second is used to ensure that universal time and coordinated universal time don't get too far away from each other. There's actually a lot more to it than that. If it was simply compensating for the differences in times, leap seconds are something that could be scheduled out in advance, just like a leap year. However, that is not the case. That's because the rotation of the Earth can change. One change is a steady change that slows down the rotation of the Earth over long periods of time. This is due to what's known as tidal friction from the Moon. The effect of this is about 2.3 milliseconds per century. Tidal friction acts very slowly, so slow that it will take 200 million years for the Earth to have a day that's 25 hours long. Likewise, when dinosaurs walked the Earth, their day would have been 23.5 hours long. Tidal friction acts so slow that 2.3 milliseconds a century wouldn't be enough to warrant a leap second within our lifetimes. There's something else. Events on and in the Earth can change the speed of the Earth's rotation. This mainly comes from things like earthquakes, which can shift the crust and mantle inside the Earth. Massive shifts in rock can change our planet's moment of inertia, which can slightly change its rate of spin. This is similar to how figure skaters can spin faster by pulling in their arms or slower by extending their arms. For example, when land that was formerly covered by Ice Age glaciers began to rebound, it slightly increased the speed of the Earth's rotation by 0.6 milliseconds per century. Likewise, the Great 2004 earthquake that caused massive tsunamis around the Indian Ocean increased the rotation by 2.68 milliseconds per century. Other similar events might tend to slow rotation or speed up rotation by small amounts. The end result is that every so often, the clocks need to be adjusted to make sure that they're in sync. The problem is, because it's so influenced by events on Earth, you can't predict when a leap second will be necessary. The first 10 leap seconds were all counted in 1972. Since then, there have been 27 times when a leap second was added. The seconds are added to the UTC clock, which is man-made, not the UT clock, which is determined by the actual rotation of the Earth. The way a leap second is added is by adding it to the last second of the year on December 31st, or by adding it to the last second of the first half of the year on June 30th. For example, normally in the countdown to midnight at 11:59 p.m., the seconds would count 57, 58, 59, 0, with 0 being midnight and the start of the new day. For a leap second, the count would go 57, 58, 59, 60, 0. The second is added at the same time everywhere around the world, as UTC is the same everywhere around the world. Where I live, the time in December is -6 UTC, so the leap second would occur 1 second before 6 p.m. on December 31st. Leap seconds historically have happened about once every 2 years. However, the last leap second was in 2016, and from 1972 to 1979, there was at least one leap second every single year. The IERA, or International Earth Rotation and Reference System Service, determines if a leap second is needed. Their job is to ensure that the difference between UT and UTC is never more than 0.9 seconds. If the clock should differ by more than that, they will announce a leap second, usually about 6 months in advance. Okay, so far so good. We introduced leap seconds to keep the Earth's clock in check with our atomic clocks. However, there is a problem with leap seconds. Getting all of the world's clocks to recognize it is a massive pain. This has become a greater issue as we rely more and more on precise timekeeping. Financial markets, computer networks, and cellular networks all require sub-second coordination of time. The infrequent and irregular nature of leap seconds is what creates the problem. Leap seconds can also occur in the middle of the business day in Western North America and East Asia. One of the solutions being floated is just to get rid of leap seconds. If you start to think about it, it really wouldn't make a difference if UT and UTC started to diverge by a few seconds. Time zones have already made it such that noon doesn't actually occur at the sun's zenith in most places. If we just ignored leap seconds, it would take thousands of years for the clocks to diverge by even 1 hour. And moving clocks ahead and back an hour is something we do all the time with daylight savings. It might be easier every 200 years to do a leap minute, which could be planned well in advance, than it would be to continue doing irregular leap seconds. There are time systems right now that are in heavy use which don't have to worry about leap seconds. Unix time is a system used by computers that doesn't bother with years, months, days, hours, or minutes. It just counts the number of seconds that have passed since midnight, January 1st, 1970. That's it. It's just one massively long number. There's no need for leap seconds because the clock doesn't have to sync with anything. The current Unix time, as I am writing these words, is 1,668,681,423. Another well-used time system is GPS time. The American Global Positioning System doesn't use leap seconds, and it's incredibly accurate. The United Nations International Telecommunications Union has proposed just adopting GPS time instead of UTC. The main objection is that the GPS system is run by the U.S. Space Force, and most countries prefer UTC, which has some sort of international oversight. GPS time is currently 18 seconds ahead of UTC. The Chinese navigation satellites are 4 seconds off of UTC. Other navigation satellite systems do use leap seconds, in particular the Russian GLONASS system. And to really throw a wrench into things, it's looking like it may very well be necessary in about 7 years to have a negative leap second, which has never been done before. The organization which oversees UTC is the International Bureau of Weights and Measures. They're the group that will determine if leap seconds will be continued into the future. Right now, getting the world on the same page in terms of timekeeping is probably more important than keeping UTC synced to the rotation of the Earth by a few seconds. We'll still know what the actual time of the rotation of the Earth is. We just wouldn't need to track it precisely for computerized transactions and communications. Depending on what the International Bureau of Weights and Measures decides, and when they decide it, it may very well be possible that we have witnessed our last leap second. Everything Everywhere Daily is an Airwave Media podcast. The executive producer is Darcy Adams. The associate producers are Thor, Thomsen, and Peter Bennett. I just wanted to extend a big thank you to everyone who is supporting the show over at patreon.com. I have show merchandise available there, including hoodies, t-shirts, and stickers. Plus, it really just helps me get this show out every single day, including, of course, weekends and holidays. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.